Hey, good morning, class, and welcome to lesson 6.1.2. Your objective today is to understand and apply the law of cosines. We're going to start by developing the law of cosines through a little bit of a proof demonstration, and then apply it to a few problems. The law of cosines. The law of cosines only helps you efficiently solve triangles for certain sets of given information. For other triangles, the law of cosines is used, which you may remember from prior math classes. The following problem guides you through the derivation of this useful formula. Assume A, B, and angle C are given values. On the diagram at the right, label the missing segments using the given information. So starting out, I got this question mark, and if I zoom in, the overall length from A to C is B. This length over here is X. Therefore, the question mark has to be B minus X. We also know, nope, I guess not. We don't have anything else to find. Use the Pythagorean theorem to write a set of equations for the two right triangles that are created by the height. So just shading those, we're talking about this triangle over here. We'll do that in blue. That equation is x squared plus h squared has to equal a squared. And in green, we have this triangle, and its formula is b minus x, that's one of the sides of the triangle, squared, plus h squared has to equal c squared. Now let's take these formulas and move forward. Use your set of equations for part A to create a single equation without h. So I'm going to take this first equation and I'm going to subtract an x squared from both sides. So therefore h squared equals x squared minus, a squared minus x squared. H squared equals a squared minus x squared. And over here, h squared equals, I'm going to subtract that b minus x squared from both sides. So I have c squared minus the quantity b minus x squared. Now I'm going to expand this out. B minus x squared. Well, remember, that's b minus x times b minus x. Now, if you expand that, you're going to end up with b squared minus 2bx plus x squared. Or another way to write this, I'm going to distribute this minus sign. So I have c squared minus an x squared plus a 2bx minus a b squared. Now, since both of these are equal to h squared, a squared minus x squared equals h squared, and all of this equals x squared, I'm going to set those equal to each other. And that gives me a squared minus x squared equaling c squared minus x squared plus 2bx minus b squared. So I've got that equation right now. I'm just going to kind of hold on to it. And in part D, it says write an equation relating C, angle C, X, and A. Well, again, this is going to be one of those trig ratios because C and X, that's the adjacent side. X is the adjacent side to angle C. So the cosine of angle C equals adjacent over the hypotenuse. Therefore, I'm going to multiply both sides by A. I have A cosine of C equaling X. Highlighting that. We're now going to combine these answers. I'm going to take this cosine of, or A cosine C, and I'm going to plug it in for X over here. If I do that, I now have A squared minus X squared equaling C squared minus X squared plus 2B times A cosine angle C minus B squared. I notice that a negative X squared on the left side and a negative X squared on the right side. So I'm going to simplify this by adding. Let's change colors on that. I'm going to add an X squared to both sides. That gives me on the left side A squared equaling C squared plus 2 times A times the cosine of C. So I'm going to rewrite that as 2AB cosine angle C minus B squared. Now lastly, I'm going to get the C squared by itself. So I need to add a B squared to both sides and I need to subtract a 2AB cosine C. That will give me, on the right side, a C squared, and on the left side, A squared plus B squared minus 2AB cosine angle C. And there is your Pythagorean, your law of cosines. Before we go and use this to solve some problems, let's talk about when we can use the law of cosines. So I'm going to try to squeeze this on the screen. What I'm noticing is I've got an A, a B, and angle C. And in the triangle up above, or in any triangle, if this is angle A and angle B and angle C, then the side opposite angle A we usually call little a, side opposite angle B we call little b, side opposite angle C we call little c. And so my angle side angle, my side angle side scenario, side angle side, if I have a side A side B, and the angle in between, I can use the law of cosines to find the side opposite. So one scenario to use the law of cosines is when you have side angle side, and you're going to use that to find the side opposite angle C. A second time to use this, and I'm going to have to erase some of this here and redo the triangle. A second time, or second way to use this, is when you actually have the three sides. So if I was to say I've got side A, B, and C, I can plug those values in and search or calculate the unknown angle C. We call this, when you're given the side, to find the angle opposite side C. So if I am given side C, side B, and side A, I can plug those in my formula to find angle C. So now let's use to find missing sides and angles. Question 27. In our previous work lesson, we didn't actually have this problem. We didn't take a look at it, but it was in the textbook. So if we were to have a situation with triangle ABC, um, angle A, the side opposite, angle B, the side opposite, angle C, and the side opposite. If I am looking for side C, I have to take a look at what information is given. And the information given is I've got a side, angle, side situation. So I'm going to use law of cosines. That's our little abbreviation for law of cosines. And that says side C squared has to equal A squared plus B squared minus 2 times A times B times the cosine of 22 degrees. Type all of this into your calculator and you get C squared equaling 10.99. Take the square root of both sides and C equals a positive or negative 3.315, so I'm going to call it 3.32. We can't have a negative, so your answer is just C equaling 3.32. So that gives us side C a value of 3.32. Now, what I can do is find the other angles. I'm going to have to, though, I don't have to, but preferably, I could use law of sines to find the other angles, or I could use law of cosines to do that too, because I now have three sides, and so I could plug those three sides into my law of cosines formula and find an angle opposite one of them. So if we remember, C squared equals A squared plus B squared minus 2AB times the cosine of C. But A, B, and C are all relative. I'm going to use my values to find angle B. So I'm going to put B in here. All that matters is if I put B in here, I have to put little b over here. So little b is 8. So I'm going to write this as 8 squared equals 6 squared plus 3.32 squared minus 2 times 6 times 3.32 times the cosine of angle B. When you start to simplify this, please simplify it in chunks. You got the right side, you've got the parts that you're adding, you've got the parts that you're going to multiply, and so I end up with 8 squared, which is 64, equaling 6 squared plus 3.32 squared, which is 46.99 minus 2 times 6 times 3.32, which is 39.84 times the cosine of B. Now we need to solve for the cosine of B. So I'm going to start by subtracting 46.99 from both sides. And that gives me 17.01 equaling, this is a negative 39.84 times the cosine of B. So now I'm going to divide both sides by a negative 39.84. That yields a negative 4 or negative 0.427 equaling the cosine of angle B. Now take the inverse cosine of both sides. And B comes out to be 115.28 degrees. Now with B being 115.28 and C equaling 22, the measure of angle A equals 180 minus the 22 minus 115.28, giving us an angle measure of 42.72 degrees for angle A. So that's using strictly your law of cosines and the triangle sum property to find missing sides and angles in a side angle side situation. Now let's go with a side 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 situation. Notice how here we have all three sides. We're basically going to end up repeating that last step, or finding that missing angle that we did in the previous problem. So my law of cosines, c squared equals a squared plus b squared minus 2ab cosine of c. And the a, b, and c don't really represent an a, b, or c. They just represent three sides of a triangle. And what's important is that this C matches up with this C. In other words, they have to be opposites. So to show that, I'm just going to say I want to find angle A first. So that means 6 is opposite angle A. So I'm going to go 6 squared equals, my other sides are 8 squared plus 7 squared minus 2 times 8 times 7 times the cosine of angle A. Six squared is 36 equals, and again emphasizing, do all of this as one step, this as a second step. 8 squared plus 7 squared is 113 minus 2 times 8 times 7 is 112 times the cosine of A. Now subtract the 113 from both sides. And on the left side, I get a negative 77 equaling a negative 112. Remember, that's a minus sign right there. Times the cosine of A. Then divide both sides by a negative 112. And the cosine of A equals 0.68, 0.6875. Take the inverse cosine, so A equals the inverse cosine of 0.6875, and angle A comes out to be 46.57 degrees. So let's label that or think of that as 46.57 degrees. Now I can use law of cosines to find another angle, but I think it might be faster to actually start using the law of sines to help us. So if this angle appears 46.57, and that's the side opposite, according to my law of sines, the sine of 46.57 over 6 has to equal the sine of angle B over 8. Now if I multiply and get rid of my fractions, I have 8 times the sine of 46.57 equaling 6 times the sine of B. Divide both sides by 6. And the sine of B equals, put that into your calculator, equals 0.9683. Take the inverse sine of both sides. And B comes out to be 75.53 degrees. And then by your triangle sum property, to find the measure of angle C, I'm going to take 180 minus 46.57 minus 75.53, and I get 57.9 degrees. Now what I would like you to do is pause this and draw a picture for the situation, and then find missing sides and angles to answer these questions. So go ahead, pause it, and then when you're done, come back and check your answer. All right, welcome back. And as you can tell, the answers are here in front of you. In part A, C came out to be 142.6 feet. Now you're rounding, depending on where you round, you might have something a little bit different, but it should be right around 142 to 143 feet. Therefore, there is enough fence. In number 2, I used the law of sines twice, once to find A and once to find B. Now what you could do is use the law of sines once, find A, and then you could have gone and used your triangle summation property and taken 180 minus 47.9 minus the 74, and that would have given you 58.1. And in part 3, using that area formula that we developed yesterday, 1/2 times 110 times 126 times the sine of 74, you end up with 6,661 feet squared. The lot needs to be a little bit bigger than that. It needs to be 6,900 square feet. So no, that's not big enough to build that house. Well, that pretty much sums it up for your law of cosines. Hopefully you enjoyed the lesson. And tune in tomorrow when we talk about the ambiguous case of the law of sines. Have yourself a great afternoon. Take care.